Good afternoon, everyone. Thank you for your time and being here. It was a pleasure to be here and having some. Pleasure to be here and thank you for giving the opportunity. So, a brief introduction about myself, a brief history about myself. So, I'm an engineer. After my engineering, I did my MBA and I started working as an analyst. And like in 2016, I did my MS in analytics. Then I started working on data science projects. So I worked for Verizon, Anthem, for a lot of data science projects, and currently I'm working at Dana on different lot of data science related projects. But today's presentation is mainly focused on the data labeling aspects of it. Data labeling and what are the challenges we face in data labeling and data preparation, more than the morning. And especially we'll talk about some of the use cases which are related to automotive industry. And so this is the overview of the content. So opportunities in the automotive industry, what we have, the different type of opportunities we have in the automotive industry, and the general approach, what we take in order to solve some of those critical problems, how to analyze the problems and how to solve the problems. And I'll be deep diving into one of the use case, the supply chain analytics use case, and further, what are the process and the challenges in forecasting the labor demand. I'll be taking one specific use case from the supply chain, and I'll try to explain what's the process of data labeling and data preparation to arrive at the forecasting labor demand. So, coming to the opportunities in this use case is we have lots of opportunities in the automotive industry. That is supply chain. We have so many use cases in supply chain. The main challenges here, when it comes to the data preparation and the data labeling, the main challenge is the data accessibility. Especially in the automotive industry, it is a very huge sector. In order to build a vehicle, there will be like 4,000 plus components in a car, and for every single component, we have lots and lots of suppliers. So, and we have to analyze to get the data from every single supplier. The data accessibility and the transparency among the suppliers is very critical for us to analyze or solve some of the critical issues in supply chain. And the next opportunity what we have is in manufacturing. In manufacturing, it's the main challenge is collecting the data from manufacturing life cycle. We have to understand what's the life cycle of whole manufacturing process and how to collect the proper data and what's the problem we are trying to solve and what are the data points we need to collect in order to solve that problem. And predictive maintenance is one of the common use cases we can see in most of the in the automotive industry. It's like collecting a lot of telematics data from the vehicles, processing it, and it's like remote monitoring and maintenance of the vehicles. Predictive maintenance is one of the main use case. And in supply chain marketing, so we have lot of AI use cases are there in supply chain and sales and marketing, where when it comes to sales and marketing, the challenge is behavioral data collection, collecting the behavioral data and analyzing the customer's data, as well as customer privacy and compliance is one of the critical issues which we need to take care in terms of data labeling and data preparation. It's like how far is too far, or is it ethical to collect some of the very confidential information about customers? We have to be mindful about that in terms of data preparation. The same goes with driver behavior analytics. We have to be a little careful in terms of analyzing data. And this is one of the use cases, like analyzing road conditions. there are lots of use cases which are coming up in this industry, especially identifying the external factors. What are the different external factors? I mean, the main challenge in analyzing the root conditions, especially like, for example, regenerative braking is one of them. Lot of companies are trying to create a feature, a regenerative braking feature in their own cars by analyzing the road conditions. This is one of the examples. Or battery maintenance. By analyzing the road conditions, in real time, we need to find out how the vehicle is heading from point A to point B. What's the gradient of the road, and how the vehicle is moving. I mean, after like 30 minutes, where my vehicle will be, in what sort of segment the vehicle will be, and do I need to cool down my battery or increase the battery temperature in order to optimize the battery performance. So all this, it's for everything we need to have. The main challenge here in this use case is identifying external factors. What are the important external factors which we need to collect for that particular problem, and how to process it. The processing power is huge because we will be dealing with lots of data points there. So the processing power is huge. So it's a general approach for any analytical problem. Identify the problem, ask the right questions, and understand the overall process, and have a right partner to support and validate the external data points. If there are external data points are needed, have the right partner to support the external data, and select the right analytical approach. Further, implement the models using different ML architectures and collect the feedback and improve upon those models. So this is general framework for any analytical models. So I'll be deep diving into supply chain specifically here. In the supply chain, we have lots of use cases, that is demand and supply forecasting, price analysis, inventory planning, warehouse management, production planning, and labor planning. So there are many use cases here, but I'll be specifically talking about the labor forecasting aspects here. From the when we talk about the labor forecasting, initially we'll be focusing mainly on the data preparation aspects of it here. So if I want to prepare, like forecast the labor demand, how many laborers I need for any specific work. First, initially I have to identify what are the different job codes the laborers are performing, and how much effort it takes for them to perform that job code, and we have to categorize those different job codes into like meaningful categories. For example, like picking, packing, replenishment, inbound or outbound, whatever it is. So we have to identify those each job codes and categorize those into a specific category. Then further, those are mapped to a type or different type of labor. What type of labor we need? Is it a direct labor hours or indirect labor hours which we are trying to perform here? We have to estimate the time required for each task. For every single task, we have to estimate the time, how much it needs, and aggregate the small tasks into meaningful categories. Then understand the patterns of the labor in order to patterns of the labor historically in each category in order to forecast the future. Coming to this slide here, this is in terms of predicting the labor can be predicted in many different ways. Especially here, I'm focusing on two different aspects here. If you want to predict the labor for short term, you can do it as well as for long term. There are different implications and different variables which actually matters for long term predictions as well as short term predictions. Suppose if you want to predict the labor for short term is always about what's happening in the current scenario. If there are any natural disasters are happening, and if there is any sort of like Suez Canal, like we had the problem of Suez Canal, which actually implicates directly on labor demand at global level. So we have to identify. COVID is one of the example. If there is a COVID impact, then that directly affects on the labor demand side, as well as the weather impact. if there is a snowstorm or any tornadoes are coming up. So that will also directly impact on the labor demand in the warehouse facilities. So we have to identify those factors, and we have to, along with the historical demand, along with the historical data, we have to feed these regresses in the model, in the forecasting model, so that we can fine tune the forecast. So without these regresses, suppose if I build the forecasting model will be able to achieve maybe around 80% accuracy. If I would able to bring or identify the right factors, what are the right factors which contributes for these kind of variations, we will be able to identify even further, and we can be precise in terms of predictions what we are trying to predict. So I'm marking them in red because these variables are not in our control. It's very highly difficult for us to predict. But coming to the green ones here, supply and demand. We know how much supply and how much demand we have for our product. Historically, we know that piece. And company strategic goals. Being in a supply chain, if there are a lot of suppliers out there, we have to identify. For example, for a third-party logistics company, if they are working in silos without any information about the company's aspects, like company strategies, are there any sort of mergers or acquisitions, or are they promoting any products, or are they doing any sort of like aggressive marketing campaigns in order to push their products? If they are doing, then we should be aware of all those inputs. We should gather all those inputs and feed some of these nuances into the model so that we can identify what will happen over the period of time. So the green ones, which are sort of we have some sort of control, but we have to work in tandem with all our partners, all the suppliers, in order to forecast any different things for that matter. And coming to the right side here, the macroeconomic indicators, which we have very less control in terms of forecasting any demand. Whether it's for this case it's a labor forecast. So we don't know like what will happen. The geopolitical interest, we have very less control on it. And the imports and export regulation, plus consumer price index, and gas prices, which we have very less control, and which we cannot really make any impact on these things. But all these factors will be directly correlated in one or the other way in terms of labor demand over the period of time. And apart from those regresses, we have to analyze about the time series. We have to analyze, are there any sort of like received peaks or shipped peaks? Are we receiving more number of goods in our warehouses facilities? Are we shipping, how many goods we are shipping? And for that, every shipping, we need for like, there will be sort of like peaks, receiving peaks and the shipping peaks. For example, in the month of November, in the month of November, we see like there's a lot of businesses will see a lot of demand, especially during the Christmas month and Thanksgiving. We have to identify those common patterns, and we have to feed those variables to the model. Additionally, along with the forecasting models, we have to have one more column or one more variable saying, see, this particular month is November month, and we have to give that data point to that model in order to identify or make those forecasts even more clear. As well as if there are any national holidays, all those things, the data points what we feed to those models will definitely help for the forecasting model to predict. Apart from that, yes. So these are the variables which we need to take care in order to build the model. Once we have all these regressors and all the data points in place, we can achieve more accuracy in terms of forecasting. And from the right side, you can see that orange line indicates the historical data, where we can see that there are a lot of spikes during the month of like November, and there's a huge spike near the end of December because of New Year sales. So historically, we see that, and yeah, if you want the blue line indicates the forecasted results. So it actually forecasts how it looks like in terms of forecast. So with all these regresses and the historical data in place, we could able to achieve almost 90 to 95% accuracy in terms of prediction. But monitoring and maintenance, whenever we deploy these products, whenever we deploy these forecasting models in the production, over the period of time, after 3 to 5 months, these model gets stale. Again, the maintenance is very much critical for all these models. So in order to achieve accuracy over the period of time, we have to identify the right parameters for that business. For example, the right parameters, when I talk about right parameters, every business is different, every model is different, all the forecasting models. We have to identify right parameters, what are the different parameters which impacts on those models. We have to input those models, and we have to customize every single model so that we can monitor those models for the period of time, and we can achieve the accuracy. Any questions?
In the example you just did, would you say that you could apply that same rigor forecasting model into a different country, for example? So if you say, hey, this is the model we use in the US, do you think those exact same features of your model would work if it just translates that to England or Japan or something else?
No, it doesn't work. That's what every single model is different, because in US during November time you have Thanksgiving, so we don't see that kind of peaks in different model. We have to identify what's the consumer pattern, what's the consumption pattern of the country. We have to identify what are the peaks. That's why I brought in the November variable in that model. If you feed those data points to that model, it will actually help to predict. And I'm also including COVID as one of my indicators there, because COVID is only one time event what we had in our lifetime. If you feed that kind of behavior to the model, it literally we are feeding noise to the data, noise to the model. So in order to make that, in order to avoid that noise, we have to feed explicitly. We have to feed that these are the dates where we impacted by COVID, and we cannot see that kind of same again. So that will help us to avoid the noise.
So with the data that you control, how did you bring that into the environment, and when did you refresh it? So obviously you probably didn't want to keep it in your data sources. So what were you doing to set that up when it came to your data model and your architecture to know when to bring it in and knew when it was refreshed and when you refreshed it? Like, how did you set that up to understand, to create your data architecture?
Sure, yeah, definitely. See, one of the best packages I tried LSTMs, neural nets. I've tried lots and lots of forecasting models, but one of the model what I use is FP Prophet. Is one of the easiest software to modeling for forecasting. I still recommend for a lot of people in terms of forecasting. FP Prophet is the one. In that FP Prophet, you have lots of APIs where you can just any engineer can build that. You don't have to be a data scientist in order to forecast. You just need to know the Python code, and if you give APIs, if you give data, that time series data. For that matter, if you give the proper time series data to that package for that API, it gives the forecasted results. And coming back to your question, how to deploy or how to manage the data pipelines. So we have to identify what are the data sources it needs for that modeling. And in terms of deployment, we have deployed that in the Airflow. Airflow is the tool which helps us to build all the softwares and build all the pipelines. it triggers based on the time or based on the event. It triggers and it builds all the required pipelines. And it's not just the data input, even the external factors for that matter. Suppose if don't need any sort of like marketing or any aggressive marketing, all those details needs to be brought in from the third party organization, and we have to feed those data inputs to the model so that we have to build the entire pipeline. So that every single variable, maybe that model might need 10 variables or 30 variables. For that forecasting model, we might need 10 to 30 to make sure that all the variables are there. Eventually, it will have to monitor those things, and if it is degrading, then we have to identify what is the root cause. We need to come up with new indicators.
Did you get those business rules then, that data and that business rules sent to the another system then to make the decision?
Right.
Okay. Sorry.
That's all we have today. We'll see you all back here tomorrow morning. I want to thank all the speakers.